Node comes with this wonderful abstraction that's called streams. There are two basic types of streams: read streams and write streams. A read stream is a source of data. It behaves like a data faucet, emitting data events. An example of a read stream is a file stream. Here, we're creating a file read stream. And as you can see, the read stream is a special case of an event emitter that emits data and events. It emits data every time there is a chunk of data coming out, and the end event when and if the stream ends. So let's see this script in action. So as you can see, there are several data events being triggered, each with a chunk of data of the file that we're reading. Each data event here gets a buffer as the data payload. But if you specify the encodings, the data payload comes as a string instead of a buffer. So here you can say readstream dot set encoding, and in our case we know that the encoding of the file is UTF-8. So let's see the effect of this. Okay, so you can see that we get strings, meaningful strings, instead of binary data. We could also use any other supported encoding here. So for instance, if you use base64, you'll see the strings being base64 encoded. So the read stream behaves like a faucet, and you can pause and resume as a faucet. You can open and close a read stream. So using this example, let's evolve this and make it emit one chunk of data per second only. So first, we need to pause the stream. So you could do readstream.pause. So we create it and pause it immediately. So it's on a paused state. And while it's paused, it will not emit data events. So we can just then here set a timeout in 1 second, so we can resume the read stream after it's paused. So it starts in a paused state, and after 1 second it's resumed, which will make it emit a data event if there is any data available. And then after we got the first chunk of data, we can pause the stream again and then repeat the set timeout here, so that it's resumed after 1 second. So let's see if there is the effect of this on the log output. Okay, as you can see, we got a chunk of data every second. Okay, let's speed this up. Okay, and then the file ended and we exit. A write stream is a stream that you write data to. An example of a file of a write stream is a file write stream. Here we're creating a file write stream, and then we're writing a string to it every 100 milliseconds. And after 5 seconds, we stop writing and end the stream. So let's test this code. We're going to tell the process, so we can So we're going to tell the process now, and node fs write stream. So you can see that we're writing 10 times a second, and then after 5 seconds we stop writing and node exits. So every time that you write to a write stream, the data gets buffered until it's flushed to the kernel. Every time node buffers are depleted, you get a drain event. So let's see that in action by binding to the drain event on the write stream. So write stream on drain. And also the write stream dot write returns a boolean that is true if the data was immediately flushed and false if the data got buffered. So we can see if it and log if it was flushed or not. Let's see this in action now. Okay, here you can see that it wasn't flushed, and then we get a drain event. Any read stream can be piped into a write stream by using stream.pipe. So we'd say read stream.pipe, and if you had a write stream here, we could pipe it. This would mean that every data event on the read stream would then be written into the write stream. Pipe also deals with back pressure. When the write is not flushed, the read stream is paused until the write stream emits the drain event. Then it's resumed. This is also why streams are great. If there is a slow client, and which makes the consumer of the data being slower than the producer, data does not get buffered. Instead of getting buffered, the back pressure happens, and either through TCP or through a file system, the source of the data gets paused until the client can recover. So let's see some uses of pipe. So let's see here an HTTP server that we created. And this HTTP server is listening on port 8080, and once we get a request here, every time we get a request, we create a write stream with a random file name, and then we pipe the request, which is also a read stream. We pipe it into that write stream file, and we also pipe we create a read stream of the current file name, which is the current source file, and we pipe it to the response. So we can see that in action. So actually the piping here corresponds to the HTTP request and response bodies. In the read stream it's the request body, the write stream is the response body. So let's see this in action. Okay, we got the current source file streamed piped into the server, and we also logged the request. But since the GET request doesn't contain any body, we will see that the file is empty. So for that, we could do something like a curl with a post request containing some data. So here it is. Made a curl request with a body, and we wrote request to this, the request body to this file. Let's see if it has something. Yes, it has, as expected, our request body. So this concludes our episode for today. I hope you enjoyed it. Bye bye, see you soon.